Hi everyone, so for this video I'm just going to go through the two-way repeated factor ANOVA. So this is a little bit different to the two-way between factor ANOVA or two-way mixed factor ANOVA, in that for this one both of your independent variables are repeated or a within design. So for this example, which is about as simple as I can do, just to showcase what I mean by repeated, is essentially just measured over time. So for this one, I've got 3 trials. So we can call them trial 1, trial 2, trial 3. And then we have 2 time points within each trial. So we'll measure at baseline for each trial, which is basically the start, and then at the end of each trial. So in this design, essentially, we have 2 independent variables or 2 factors, and both of them are measured repeatedly. So the same person, for example, will be subjected to each of these combinations. So if we look at it in this way, this would be person 1, this would be person 2, and then this would be person 3. And if we had 10 people, we'd have 10 rows. This is different to the between factor design ANOVA, where you would essentially have an entire column listing which conditions you would have. So a good way to remember it is between factors go top to bottom in SPSS, where repeated factors go across the columns this way. Okay, so for this data, I've just made up some heart rate data. So essentially what we're trying to find out is heart rate influenced by the trial, so trial 1, trial 2, trial 3, and is that different at baseline or at the end of an exercise bout, let's say. So if we're going to run this, we do it slightly differently to a between factor ANOVA. So we'd have to go analyze, general linear model, and then repeated measures, because we have at least one of our factors that's measured repeatedly. So I'm just going to reset this because I've already done it. So within subject factor is the same as a repeated subject factor. So for this one, we're going to say time. And for that, we have 2 levels. So it's essentially saying how many times do you measure something over time. So we have baseline and we have end. If we had baseline, mid, and then end, we'd have 3 levels. But we only have basically at the start of exercise and the end of exercise. And then we have 3 trials, so we can just call this factor trial. And we've got 3 levels. If we had 10 trials, we'd have 10 levels. And then you press define. So you need to get these in the right order, so SPSS lays it out quite nicely for you. So we don't have a between subjects factor in this because it's a repeated ANOVA, not a between factor ANOVA, or a mixed ANOVA, which would have a repeated as well as a between factor. This one's just purely repeated. So essentially, the baseline time point for the first trial would go here. The baseline time point for trial 2 would go here. You can see it's 1, 1, then 1, 2, then 1, 3. So it'd go baseline acts as 1, so 1, 1, 1, and then it says 1, 2, 3 for the trial, so 1, 2, 3, and then the inverse, so we'd have 2, 2, 2, 1, 2, 3, so end would be 2, 2, 2, and then trial 1, 2, 3 would be 1, 2, 3. So you can just copy and paste these straight over. And then we also want some essentially post-hoc tests based on our marginal means. So we can click our DuPont Ferroni over SIDAP, but it's all preference. And then we can go to options. You can add some descriptors. Levine's test, we don't need it because we don't have a between factor. We have a different assumption. And we can go back and check some of the other assumptions as well, like normality. We're just assuming that these have been met. So I would click this, and then also to get some visuals, you can examine how they look against one another here in relation to our dependent variable, which is heart rate. And then we can just click OK. Yeah, homogeneity test ignored because there are no between factors, fine. So if you want to look at the code, what these mean, so time point 1 means baseline. So when you see time 1, that means baseline. If you see time 2, that means end. And then if you see trial listed by 1, 2, 3, that means trial 1, 2, 3. So one of the first assumptions, you have normality, which is the same across the ANOVAs, regardless of how your independent variables are, whether they're between or repeated. But here we have Moltke's test of sphericity. So this one's essentially acting in the same way as Levine's test does for the between factor. It's checking the variance across your scale variable. If we go back to our input, we can see we've got scale variables here. They're not nominal variables. So it's checking if essentially the variance is equal across these. And we don't have an output for time or trial, I think because they've got too few levels, but we do have an output for time times trial. So if this value here was less than 0.05, we'd have to use a correction, but it's higher than 0.05, so that assumption has been met for the interaction p-value. A lot of the times it doesn't really matter, but sometimes you do have to pay attention to this. If, for example, time here, this is the box we're interested in right now, if you've got the assumption of sphericity and the p-value was significant, but the greenhouse gas year correction was not significant, then you'd have to take the greenhouse gas year correction p-value if this assumption had been violated, and you'd have to take the greenhouse gas year correction. But it doesn't really matter here because you can see whether it's assumed or not, they're all significant for time. So basically it's saying that heart rate changes over time. But the inverse of that for trial, we don't have a significant p-value, but it's not really interesting, the main effects on their own, whether it's time or trial. What we're interested in with a two-way ANOVA is the interaction. So time times trial, if we look at the assumed p-value, again, we would take this assumed p-value of less than 0.001 because Moltke's test has been satisfied. If this wasn't significant, if this was significant, let's say 0.003, we would actually take the p-value underneath, which would be 0.004. It doesn't matter because they're both significant, but it's just worth mentioning. So what it's saying is that heart rate is influenced by how time and trial interact with one another. That is, when heart rate changes over trial, it's dependent on time. Or when heart rate changes over time, so that's the end to the baseline, it's dependent on the trial. So we can dig a little bit deeper for some of the post-hoc tests. So we don't have a between subject factor, so we can ignore this. And you can skip a little bit easier to some of these. So this is what we're interested in here, these pairwise comparisons box. So again, these codes are important. So if you go to the top again, this is what they mean. And we can just nip back down here again. So what it's saying is for trial 1, when you compare time point 1, which is baseline, versus time point 2, which is the end of exercise, for trial 1, baseline versus end, you have a significant difference. So we can have a look at the raw values again here. What was that again? So trial 1, baseline versus trial 1, end. It's saying that these two groups are essentially different, or these two groups of data, it's the same people measured over time. So these data are different to these data, which you can kind of tell by looking at it, that heart rate's higher here than it is here. Okay. And then you can do the inverse. So you get the exact same p-value, so it's only swap the order around, which makes it doesn't make any difference when there's only 2 levels. If we had 3 levels or 4 levels, it would make a difference. We'd have all the other combinations. Likewise for trial 2, when you compare baseline versus end, you get a difference. And then trial 3, baseline versus end, there's a difference. So it's saying that when you compare baseline versus the end, for each trial, they're different. Now you can do the inverse as well. So if we go down here, it's split it around. So now it's saying, okay, for each time point, so baseline, is trial 1 different from trial 2 at baseline? And it is. Is trial 1 different from trial 3 at baseline? Yes, it is. But then it's saying time point 1 is 2 different from 3, because we have a bigger combination possibility here, because there's 3 levels within our trial, so there's more comparisons to make against each other, as opposed to the previous one where there's only 2 time points. So yeah, that's pretty much it If you wanted to check normality, I'll just quickly show it now. We can go data, actually, descriptive asset analyze, descriptive statistics explore, and we can just copy and paste all of these into our dependent list. We can click what you want here, but you want normality plots with tests at least, and then we can start to check for normality as well. You would do this before you'd run the ANOVA, but so here it's saying that baseline trial 1 is not normally distributed, but the others all are. So you could look at log transforming this first set of data, which in our input, so baseline trial 1 would be here. So I think it's because this is not the same as these two. So this is acting as an outlier essentially. So you could do a natural log transformation of these data and then run the normality test again. But that's pretty much it. Hopefully you found it useful. Please like the video and subscribe if you found it useful. Okay, thank you very much.